This lesson is about trapezoids. I need you to interact with this lesson. You'll have to pause it at certain times so that you can finish taking your notes. I'm going to ask you to do a couple activities, and again, I need you to pause the presentation so that you can do what I've asked and then start back up so that you can see what conclusions you're supposed to be finding. This lesson 6.5, trapezoids. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Exactly one pair. So either the top and the bottom are the parallels, or like the left and the right are the parallels. Don't think that it's always the top and the bottom. Depends which direction the trapezoid is turned. So I've given you a couple versions of trapezoids on your notes. Some terminology that goes along with bases, or with trapezoids, it would be bases. Bases are the parallel sides of the trapezoid, not always the bottom and the top, but whichever two are the parallels, those are the bases. Legs are the non-parallel sides of the trapezoid. The ones that are not parallel are the legs. So let's practice that as we look at the diagram. I've labeled the first trapezoid A, B, C, D. Which segments are the bases? That would be segment AB and segment DC. The parallel sides are the bases. Which ones are the legs? Segment AD and segment BC are the legs, the two that are not parallel. And the last term is base angles. Base angles would be the pair of angles that share the same base. The pair of angles that share the same base. So any angle in a trapezoid would be a base angle, but as you talk about base angles, you need to pair them up. Which two pair together? So let's pick out a base on the first trapezoid. Let's just go with segment AB. So with that base, angle A and angle B are your base angles. In other words, angle 1 and angle 2, that's a pair of base angles. Now angle D and angle C would be another pair of base angles because they are both sharing base DC. If you look at the trapezoid on the right, I'm going to highlight the short side for the base. So which angles are the base angles related to that base? I know I haven't put any letters there. But how about the 1 and the 2? Those are a pair of base angles. Pause the screen if you haven't gotten all your notes taken. Okay, the next term is isosceles trapezoid. An isosceles trapezoid is a special type of trapezoid. Its legs are congruent. From the last screen, legs are the sides that are not parallel. So in this one, the left side and the right side, if those are the same length, this is an isosceles trapezoid. Got the parallels. Those are the bases. So then if the legs are the same length, it's an isosceles trapezoid. We use the term isosceles on a triangle to mean two or more sides congruent. Related to trapezoids, isosceles would mean two sides congruent, specifically the two legs, not the two bases. It's the two legs that are congruent. Okay, here's an activity that I need you to do. Actually, two activities. I'm going to cover up part of it here. Okay, the first one, I need you to make a trapezoid using the lines on your paper for the parallel lines. Make one leg longer than the other. Measure the angles in the trapezoid. So to clarify the directions here, you're making a trapezoid on your paper. So use one line on your paper and then go down. You're going to be doing some measuring with a protractor, so maybe go down about 4 lines to give yourself good space. More is better than less. And then highlight another line on the paper. Make one longer than the other. Connect with your straight edge. Connect. And you should have created a trapezoid. This side would be parallel to the bottom because you used the lines on your paper. Okay, now grab a protractor, measure the angles in the trapezoid. Measure all 4. To kind of check your work, what should the 4 angles in the trapezoid total up to be? We learned the other day, in any quadrilateral, the 4 angles will add up to 360 degrees. Okay, so pause this so that you can do your measuring. Now, if we were doing this in class, we would compare and see what was going on. What really should happen in your measurements, you should have some angles that add up to 180 degrees or really close to it because of a little error that we allow in measuring. But you should find that angle 1 and 2 in my picture add up to 180 degrees. That would be because they are like same side interior angles related to the parallel lines. And then also, your angle 3 and angle 4 should add up to 180 degrees. Again, if you use the right-hand side as your transversal, those are like same side interior angles. So you've got some supplementary angles going on in trapezoids. 1 and 3 do not add up to 180 degrees. If you see what angles or what sides would be parallel, that doesn't fit with angle 1 and 3 being same side interior angles. Okay, next exploration. This time I want you to make an isosceles trapezoid. So use the lines on your paper again, but you have to make the legs congruent this time. So if you make a short side and then a long one, I'm not sure if I would connect the ends on this, if I would have the same length. So connect on one end and measure that. How long is it? Maybe it is 3 centimeters. Well, then on the other end, you have to angle it so that it is 3 centimeters also. So if I measure out to here, maybe that's 4 centimeters. I don't want that. So I need to put the ruler at the corner and measure to see where would it be positioned so that it is also 3 centimeters. So then you've got a little part that either you have to add on or take away from that right-hand end. So make the 2 legs congruent. They have to be for this next experiment to work. So take some time and do that good. Okay, now if you're back, we've got these 2 parallel. You've made the legs congruent. I don't know if yours are 3 centimeters or not, but I was using that as an example. Again, measure the angles in the isosceles trapezoid. You'll have to pause this if you haven't done that measuring yet. Okay, so looking at one example isn't the best, but if we were doing this in class, we could compare. And I'm going to give you some numbers for example. Okay, this could be a, let's go 50-degree angle. Then the one up above it would be 130. Based upon the first experiment that we did, those would be supplementary. Now if you made an isosceles trapezoid, you'll find the angle over here, that base angle, to be the same as the one on the left. And then the top one on the right will be the same as the top one on the left. In an isosceles trapezoid, there is like a line of symmetry. If you would go right through the middle of that trapezoid and fold it, the two halves would match. The angles would match up on each end. Did it work for you? All right, let's get down the notes related to those two experiments. And actually, you might notice that these are both about the isosceles trapezoid. Just a generic type of trapezoid does not have a certain pattern. That 180-degree supplements really is nothing unique because we already talked about that with parallel lines and transversals related to same-side interior angles. So you really are just using that theorem as it applies to the trapezoid diagram. So theorem 6.1.2, if a trapezoid is isosceles, then each pair of base angles are congruent. Again, pause this so you have time to write it down. And I'm going to draw you some pictures. If a trapezoid is isosceles, so I'm going to draw you a little picture. If this is an isosceles trapezoid, then each pair of base angles are congruent. Let's label on that picture. Let's go A, B, C, D. So then angle A is congruent to angle B, and angle C is congruent to angle D. Does that make sense? Okay, theorem 6.13 is pretty much the converse of the first one. So if a trapezoid has a pair of congruent base angles, now let's draw the picture to have congruent base angles. And it says we just know that it's a trapezoid with congruent base angles. Then we will know that it's isosceles. So what's the conclusion this time? We'll label it in the same way. Isosceles would mean segment AC is congruent to segment DB. Those two legs would be congruent. So how do you know which theorem you're using? It depends what you start with. Do you start knowing that the segments are congruent? Or do you start knowing the angles are congruent? That will help you know which one to use as a reason in some of your problems. Okay, find the missing angle measures in this trapezoid. And I'll mark the parallels so that you're not questioning which ones were my parallels. Okay, pause for a little bit and find those angle measures. Okay, if you're back, you should notice that it's an isosceles trapezoid. So 118, the base angle that goes with angle A, they're along that same base, is also 118 degrees. Angle D is related to angle A because they're supplements. So subtract, and you should get 62 degrees for angle D. Well, the base angle that pairs with that, angle C, is 62 degrees. And you might also notice and check that angle B and angle C add up to 180 degrees also. Notice that all four angles add up to 360. Okay, so we started this one using theorem 6.12 because it had the segments congruent. Okay, on this trapezoid, find the missing angles. All right, are you stuck at all? Is this trapezoid isosceles? It is not. So you're not getting 78 degrees here. That is not 78 degrees because it's not an isosceles trapezoid. So how are you going to find the angles? Simply use the supplementary idea. Angle M and angle R are supplementary. So that angle is 102 degrees. Angle P and angle O are supplementary. So angle O is 20 degrees. Might not exactly look like 20 degrees, but we're using the numbers that I put up there. Again, all four angles will add up to 360. Okay, find the missing angles in this trapezoid. Is it isosceles? Yes, it is. So this should have been 105. This would be 75, and this one would be 75. The bases were segments ST and RU. So think about where you would fold it if you didn't get that right, especially. Think about folding it so that the two halves match. Okay, the next term is mid-segment of a trapezoid. This is a special segment that connects the midpoints of the legs of a trapezoid. So pause so that you can write the notes down. Okay, you'll notice that I have a construction on here, so grab your compass and straight edge. I want you to actually construct the mid-segment in a trapezoid. Now all you have to do is construct two midpoints, and we have done that before. It says start with the trapezoid using the lines on the paper as your parallels. So draw something similar to the trapezoid that I have there. Use the lines on your paper to make the parallels. Does it need to be isosceles? No. It's probably better that it's not. We'll make that side look longer. Okay, now you need to do the midpoint of the legs. So using point A and B, go from A, make the arc that is more than half of the length of segment AB. Now don't change your compass. Pick it up and go to point B and do that same arc. When you connect these two intersection points, you will be finding the midpoint of side AB. So that's the midpoint of one leg. Now go to C and D and do the same type of thing. Use your compass, not freehand like what I'm doing. All right, and when you connect those two midpoints, just with your straight edge, connect them, that is a mid-segment. How does it look like it's related to the sides of your trapezoid? Hopefully, it would look like the mid-segment is parallel to the bases. And also measure it. Is it as long as the bases? No, it's longer than one and shorter than the other. What you should find out is this type of a relationship. If this were 4 centimeters, one base might be 3 centimeters and the other 5 centimeters. What relationship is there? Well, 4 is exactly halfway between 3 and 5. So the mid-segment is the average length of the bases. If you take 3 and 5, add together, that's 8. Divided by 2, that's 4. That is the length of the mid-segment. You probably have some decimal numbers, but see if that worked. That'll tell you whether you did your construction extremely accurate or not. Okay, so here is the two-part mid-segment theorem for the trapezoid. I don't have a theorem number for this one. I don't think your book actually numbered it for some reason. So call it midsegment theorem for a trapezoid. Two things about the midsegment. The midsegment is parallel to the bases of the trapezoid, and the length is half the sum of the lengths of the bases. So that would be like the example that we just did. So I'll give you some more numbers for you to put in your notes. Okay, so you would end up with this being parallel to the bases. So that would mean like these two angles are congruent, corresponding angles. These two angles are congruent, again, corresponding angle postulate. The lengths, if this one is 10 and this one is 28, the midsegment would be 10 plus 28 is 38, divided by 2 is 19. The length of the midsegment is 19. Pause as you need to. Okay, so what's the length of the midsegment on my example? Should have been 17 inches. Now this one you're finding the missing base, so it's kind of going backwards. So 26 plus b divided by 2 has to equal 30. So what's the missing base? Okay, steps. Multiply by 2. 26 plus b equals 60. Subtract 26. And b is 34. Notice that 30 is halfway between 26 and 34. It's 4 bigger and it's 4 smaller. And centimeters would be our label. Angle measures. This is a midsegment. Like it shows, midpoints parallel. We've got some corresponding angles that are congruent. And you really could even go further. Use the linear pair idea. Oops, not 180, sorry. 100 degrees. 120 degrees. So you can find all the angles based on things that we've studied. Okay, that's our lesson for today. The assignment that you're to work on is page 334, numbers 1 through 30. Some review things. This is doing calculations with fractions. I don't want you just to plug it in, so I want you to show me some evidence. How do you work through that? So show evidence on those last problems so I can verify that you really did do them yourself. That's the end of the lesson.